some of the questions to solve. Did you people try it or not? Anyone? Is there anyone from who has tried these all questions? I mean, notes are to draw these vector triangles. किसने try किया?
No, sir. This one?
Yes. As I told you that you have to use the compass and your protector to find the resultant force. So I believe that it would be. I mean, if you have not yet practiced, just try it. It is not that WWE is that you are not advised to try it at home. You have to do it. So please try these questions and s- tell me about the difficulties. I mean, I will give you some of the questions from this worksheet, but I believe that uh, I have uploaded some of the files in terms of books in the group, right?
Yes, sir.
Yes. So we will be doing all the stuff, inshallah, from there, and I believe that it would be clear to you. So moving forward, let's talk about the second aspect of the force, that is Newton's second law. Okay, then I will move to the moments and momentum and all that stuff. So when I talk about Newton's second law, the questions are asked from this topic. They are that one of them is the statement of the question, statement of Newton's law. Second aspect of the questions is actually recall of the equation. You have to recall the equation, right? Which is very famous. I believe that everyone knows that equation is F equals to ma. And third aspect of this all data is calculations. Okay, so we usually have some calculations based on this topic. So I believe that we will cover all the areas today, inshallah, and then our forces and accelerated motion will be covered today. Okay, so first, when I talk about Newton's second law of motion, it is stated that when there will be a resultant force, what will happen? In the presence of resultant force, the body accelerates. Okay, is my voice clear as compared to the previous lectures, or it is muffled?
Sure, it's there, but it's kind of more louder.
Zero.
Is it more louder? So should I change my volume?
I mean, yeah, a little bit, like very little bit.
Okay, take a minute. Now check this one out. Is it now the volume is fine?
Yeah, better.
Okay. In the presence of resultant force, resultant force, actually what happens? A body accelerates. Okay, a body accelerates. So when the body accelerates, law starts right from here. The acceleration is, you have to write from here. This is the exam stuff. Okay, this is for exam. So the acceleration is directly proportional to, yes, can anybody tell me? Acceleration is directly proportional to
Force and mass. I mean force.
force, resultant force, not force. You will write that acceleration is directly proportional to the resultant force. Okay, and inversely proportional to, you have to write it as it is, then you will be able to score 2 marks. Inversely proportional to the square of distance, sorry, not square, actually I just switched my tune to A2. Inversely proportional to mass of the body. Okay, is it clear to you? So it is just the statement what you have to write and you will score the marks. Now I'm going to talk about the mathematical aspect of that. So mathematically, you know, force is directly proportional to, sorry, the acceleration is directly proportional to force, and acceleration is inversely proportional to mass. That is why I can say that you people can just simply write that equation, that F equals to or F by M equals to A, and that will lead you to F equals to MA. That's simple. Derivation is not included in your syllabus. It's not actually a derivation. It's very simple to understand. So I believe that it would be very clear to you. And the main situation or the main area which is to be addressed here, that is not the calculation based on the force. The main area of interest is how to calculate the resultant force or how to find the resultant force. So when you people are calculating the resultant force is actually calculated by the method what we have discussed in the last lesson. Last lesson में हम लोगों ने क्या discuss किया है? We discussed how to find the resultant, isn't it?
Yes, sir.
So we just knew क्या resultant को calculate कैसे करना है. So that all is actually the way what I will need to use here. So I'm going to give you few examples, and then I will move to the next area of application. For example, this is a block and its mass is 2 kg, and if it is not affected, or let's say it is placed on a horizontal surface, and that surface is having no friction at all. So a force of 200 Newton is applied on it. So इसका mass थोड़ा ज्यादा कर लेते हैं. Suppose it is 20 kg. How much is that? 20 kg. So what will be the acceleration produced in it? Can you calculate acceleration for me? Acceleration is F divided by M, and that will be 200 Newton divided by 20. So your answer will be 10 meter per second square. Right? Is it clear to you? Is this clear to all of the students?
Yes, sir.
This was your case number one. Now the case number two is uh, just an induction that mass is how much? Mass is 20 kg. Same body is placed on a rough surface, right? Let's say it is placed on a grass or some sort of a rough surface, and due to that surface, when you are going to drag it, or when you are going to apply a force of uh, how much force I applied, 200 Newton force I applied in this direction, but now there will be a friction, and suppose that friction is your 60 Newton. Suppose, do you people have calculators? I have just selected a random value, so it is 60 Newton. So can I say that now the acceleration will be equals to 200 minus 60 divided by 20 kg? It is 20 kg. So do you agree?
Sir, I have a question.
Yes.
Wouldn't be considered 200 Newton because that's the direction the object will move in? Because, like the force acting forward is like more, so the object will be moving more, so
Mm-hmm.
like forwards, and then it like shouldn't be considered only 200 and just because the direction is not the object is anyways not going to move in the resultant force, like in the resultant
But
direction. So should we
okay, okay,
shouldn't we consider only 200?
okay. I'm going to justify that for to you. Actually, in the previous case, as I told you, that this body is under the influence of only 200 Newton force. So there was no force in the backward direction, right? No force in the forward direction. example, then I will come back to your question. Okay, then
Okay, sir.
you will tell me the that whether you got the idea or not. I hope that. Is Zainab in the class?
No, sir.
Okay, it is a 200 Newton force, and you are having a support of another student who is going to apply 100 Newton for you, and the mass of the body is 20 kg. Now, Mariam, tell me what will be the acceleration?
Do
Yes,
I test my theory or do I test yours?
you have to apply yours.
Okay, just a second. 200.
Okay,
Could you share again, please? No, I can see it. I can see it now. I can see it.
do you see that?
I can
Everyone,
see
please
it
calculate the
now.
acceleration for this situation.
So it will be 10, 10 meter per second, the acceleration,
10
right? 10 meter per second square.
Okay, okay. Why did you not consider this force? Because that was the force in the same direction.
Oh yeah. Never mind. I got it. Okay. But
You
like,
got the idea?
okay, I got that why to why yeah, I just got that why I need to consider the force which is like in the same
Yeah.
direction because the object is anyways going in the same direction, so I have to consider all the forces going into the same direction. But like in example number two, why do I have to consider 60 degrees? Like why should I subtract 60 degrees for some reason?
If you are taking the favor of this 100 Newton force, which is in your direction, then why should you not consider this 60 Newton, which is opposing your motion? So remember one thing, everybody, that when we are talking about the multiple forces acting on a body, I mean the force which is included in F is equals to ma formula, that force is always your resultant force. Never forget this. Resultant force. Is this clear to all?
Yes, sir.
Right? If the forces are in the same direction, they will be added together, as we have discussed earlier. If forces are in opposite direction, they will be subtracted. I told you the resultant will be calculated by the same method as we have discussed in our previous lecture, that whatever the direction of the forces is, resultant will be here 100 Newton is on that side, 200 Newton is on that side. Sorry, here it will be 300 Newton in the upper one, 300 Newton. Lowercase, it is 100 Newton in this direction. If it is 100 here, 200 here, then resultant will be anywhere here by using Pythagoras theorem. In the same way, resultant will be anywhere here. So first you will find the resultant and then you will apply that in the equation. Is it clear to you?
Yes, sir.
Okay. Any confusion?
No, but I have a question that the first case in which there was no resultant force, that's the ideal one, right? Like you can't actually achieve it, right? Because there's always a force of
Actually,
like opposing force of
okay.
friction.
Wait. I'm going to give you the, I mean, the practical situation. Whenever you are going to apply this equation A to calculate F or whatever, that is F driving minus F resistive. Okay, the forces what are in the direction of motion minus the forces which are in the opposite direction of motion. So when you are going to have this situation. If no opposition force, then only forward force will be there in case number one. Everyone clear?
Yes, sir.
क्या है? Okay, give me a second, please. Okay, sorry. So is this clear to everybody? Everyone?
Yes, sir.
Okay. Sorry, I had some negotiation with my kid. That's why. Okay. So is it clear to all? ये बाकी लोग कहाँ पे हैं? Where are the other students? Ariba, Khadija. Yes. Do you people hear me?
Yes, sir.
Yes, sir. My internet's just
O-
really slow, so it's like a bit laggy for me. That's why I'm not speaking much.
Okay, no problem, no problem. But is it clear to you? When the questions which Mariam asked me, did they give you a clear concept from the student's point of view, from the student's perception, that whatever the problems you have or wherever you are facing some problems, will you be able to handle those all? Is it clear? Yes. हाँ जी, खदीजा एंड मरियम, खदीजा, सॉरी, खदीजा एंड अरीबा, बेटा, इज इट क्लियर टू ऑल ऑफ यू?
सर रिपीट कर सकते हैं?
डू पीपल हेयर मी?
यस सर.
हेलो? यस मरियम, आपको
Sir,
आवाज आ रही है मेरी?
yes, we can hear you.
ओके, गुड। बोलोगे तो मुझे पता चलेगा क्या है।
सर
मैं
बोलिए.
अच्छा, मुझे सुनाई नहीं दिया रहा था ना, इसलिए मैं खुद परेशान हो गया था कि वेयर आर ऑल दीज किड्स गॉन। ओके, सो मूव ऑन, नेक्स्ट पॉइंट पे आते हैं। एक्चुअली व्हेन वी आर टॉकिंग अबाउट द न्यूटन्स लॉ और द रिजल्टेंट फोर्स, there are some areas what I have to describe with के resultant force and momentum. Actually, I am going to switch to the topic of momentum, right? Because resultant forces में से इतना ही है, कोई बहुत ज्यादा questions नहीं आते. But these are the areas from where the questions are mixed with your in your parts in your past paper. Okay, okay. So momentum. What is momentum actually? It is the product of mass and velocity, right? It is the product of mass and velocity. This is the exam definition. Remember one thing. In your daily life, momentum is impact of motion. What is momentum? Momentum is basically impact of motion on a body. Yeah, impact of motion of a body, you can say in this way. So when I say that the product of mass and velocity, so it is represented by P, and its unit is meters, sorry, kg meter per second. Either you can write this one or you can write Newton second. Kg ms minus 1 भी लिख सकते हो, and you can also write Newton second. So remember one thing, what is its formula जो आपको एग्जाम में याद करना है? Yes, there are so many equations from this one. Remember one thing, ये एक अच्छा टॉपिक है, but you have to make clear P is equals to mv, right? This is the this is what you have to consider for momentum. Okay, is it clear from my side? So that is why its unit is kg ms minus 1. ठीक है जी? Do you people hear me?
Yes, sir, got it.
Okay. The next is the next situation is, for example, if you are having some mass of the body, suppose I have a 2 kg body and that body is moving with a velocity of 5 meter per second. It is very easy, and I believe that for you people it would not be inshallah problematic, these simple calculations, right? So its momentum is 10 kg meter per second. But the problem is problem is change in momentum. Okay, what is the problem actually? Change in momentum. Now my question is that what are the factors do you see which can cause the change in momentum?
Change in mass or velocity?
Changed by mass, or you can simply say that mass is one of the factors.
Sir, how about like an
Okay.
unbalanced force?
Oh yes, I am moving towards that. Perfect. That was the thing what I was expecting from you people, that you have to ask me that how it is related with how it is linked with force. So momentum is directly proportional to mass. If you are increasing mass of a body, its momentum will be increased, and if you are decreasing, it will be decreased. Secondly, its velocity. This is very important, very very important. Okay, velocity. What is velocity actually? It's a vector or scalar.
Vector.
Vector.
So in vectors there are two possibilities for the change: the magnitude change, is it magnitude change, and what else? The second thing is direction change. So momentum is changed due to both of these changes. You have to take care of this topic, that in momentum is changed most of the times momentum changes takes place due to magnitude of velocity and direction of velocity. So when I will talk about this area, you have to be very careful. Just consider one thing, that momentum is changed due to both magnitude and direction of velocity. So momentum is changed due to both magnitude. Magnitude, I mean, are you getting it? What does it mean by magnitude? I mean, magnitude means amount of speed and direction of speed. I will write speed here, right?
Like
So speed
magnitude.
means that when there will be a sort of magnitude of motion, I mean it's that speed. Okay. For example, if I
Sir,
will say yes,
but like isn't magnitude basically the size or the extent?
yes, size exactly. Okay. So for example, if I have a body like this and its mass is 2 kg and it is at rest, that body is at rest. So when it is at rest, can you tell me its momentum, please?
Would
Yes,
be
Ariba, what will
zero.
be its momentum? Mariam,
It would
can
be
you
zero,
tell
Um,
me?
right?
would it be zero? I mean, I'm not sure.
It
Like
is zero.
Khadija,
Yes, sir.
zero.
can you tell me what will be the momentum of this ball?
Because like it'll be like zero because it's at rest. So no distances or direction is covered.
Yes,
सर
do you
आपको
hear me?
आवाज आ रही है?
आप लोगों की मुझे आवाज नहीं आ रही. Maybe I am having some problem with my headphone.
Probably.
Yes. So now I have settled down the issue. So मुझे बताइए, what will be its momentum here?
It would be like
Zero.
zero.
Yes, well done. Momentum is zero. Perfect. Now, for the same ball, I have switched this ball. Its mass is 2 kg and its speed is now, uh, its speed is, let's say, 4 meter per second. So, what will be its momentum?
8
8. Very good. 8
kg meter per
kg
second.
meter per second. Okay, now I will give you give you a situation that, for example, if the same body is moving, I mean, this was the direction of motion of this body. This was the direction of motion of the body. Okay, are you getting it? This was the direction of motion. So
Yes, sir.
actually, this is its direction of motion. But now, if I say that the same body is there, but the body has changed its direction of motion, it is 2 kg body and it is moving with the same speed, but the speed is now in this way. It is 4 meter per second. From this step, I'm just reaching from this step to this step. So for that purpose, I can draw this diagram here. It is your 2 kg body and it was moving with the speed of 4 meter per second here. Okay, this was its mass was 2 kg. Here its mass is 2 kg. Okay, so you know its momentum is 8 kg ms minus 1. But what will be momentum here, or how will you calculate momentum here? I mean, I'm not going to examine you, but it will be 8 meter per 8 kg per meter, kg meter per second in this direction, kg meter per second in this direction. So should I say that momentum is changed?
No.
Okay, so when you are defining it, what did you define? It is the product of mass and velocity. So when the velocity has when the direction of the velocity is changed, so do you believe that velocity is changed?
There may be a little change. I mean, it wouldn't stay the same, I think.
It is changed. It is. Remember one thing, the velocity is changed. So when velocity is changed, actually you can say that yes, the momentum is changed. So when your momentum is changed, you can simply say that yes, momentum is changed here. Momentum is changed.
Changed.
Okay, because of change in direction. Because of change in direction. So remember one important thing for your notes, that momentum is a vector quantity and its direction depends upon the direction of velocity. Right? What is momentum? Momentum is a vector quantity and its direction depends upon direction of velocity. Okay, so will it be clear to you that it's changed the direction, right? And direction of momentum depends upon direction of momentum depends upon direction of velocity. Is it? Are you getting it?
Yes, sir.
Okay, so never underestimate this momentum. that it is a vector quantity. What is momentum? So momentum is a vector quantity. What is actually momentum? It is a vector quantity. ठीक है?
Yes, sir. Got it.
Momentum is vector. So that is why when I make this statement, I say, आपको एक याद होगा, there was a question, and that question was, if a body is moving in a circular path, right? At in that circular path, if the body is having same speed, speed of the body is same. Speed is how much? Let's say 5 meters per second on all the points. So that body has same speed, same mass, but what is changing?
Momentum. I mean, if it has the same mass and same speed, then
Yes,
why would the momentum change?
throughout
The
the circle,
direction. The direction.
its momentum changes.
The direction
Okay,
changes.
its momentum changes if a body
But
is
why
moving in
is
a
the
circle,
momentum changing?
because its velocity, its direction changes,
Okay.
because its direction is changed. Rest all of the things are same. Direction is changed. Is it clear to all of you? Remember this thing. This is very important to know that momentum has a greater impact when we are considering velocity. I mean direction, right? That is why I told you that here there was a concern of force. I will come back to this point, okay, and there I will explain you that why I have considered that its momentum is changing and where will be, what will be the effect of this momentum change. Now I will give you some other examples of momentum change, and then I will move to the next topic, and that is momentum change in re- rebound case, or you can say that momentum change in straight line, and in rebound case momentum change in straight line. When your
So
body is
what if
moving in a straight line, yes, yes, Khadija,
so it's Mariam, but like what is rebound case?
बताते हैं पुत्र, just a second, देखती जाओ तुम. For example, this is a 2 kg mass, okay, and that mass is moving with a initial velocity of 4 meter per second, and after some time its mass is same, 2 kg, because mass is not going to be changed here, but its velocity is now increased to 6 meters per second. That is its v. So what will be change in momentum in this case? Change in momentum is represented by delta p, and it is your mv minus mu in this case. Please remember this equation. Bit by bit, I'm going to add up your topic. So change in momentum का formula क्या बताया मैंने? mv minus mu when the direction of motion is not reversed. I'm strictly talking that when the direction of motion is not reversed, then you will use this formula. Delta p is equals to mv minus mu. So the ball is, I can just make it more easy for you. How? Just take this m common, okay, and it will be v minus u. That is change in momentum formula. Okay, Ariba, is it clear to you?
Sir, could you explain it a little bit more?
Yes, of course. I'm saying that when you are saying that this is a change in momentum case, check karo. What is momentum of the body here? Let me call it P1. What will be its momentum? Its mass and its velocity. So what is its velocity? U. Is it? Ariba, is it clear? And what is momentum here? let me call it P2 or P final. It is mass at this point and velocity at this point, which is V. So when I talk about change in momentum, what is then change? Change is always, final minus initial. Is it? Are you getting it? Yes. Is it clear to all or not?
Yes, sir.
Sir, could you explain like how to basically apply it, because I can't really get the application
Okay.
part.
Yes, application area पे आते हैं. Just a second. Ariba, is this equation clear to you? Ariba was stuck in the equation. So final momentum is your this one, m into v, and initial momentum is your m into u. So final change क्या होता है? Change is your final minus initial. So I just subtracted these two values, final minus initial. So I got change in momentum. So is this equation clear to all of you? So then I took mass as common and I made an equation that it is v minus u. Any confusion in this equation? I'm going to apply that. Ariba, is there any confusion? Because you asked me and I
No
have explained
confusion.
it again. No confusion. Very
No.
good. Okay. So what was mass? Mass of the body was 2 kg, regardless of the units. Just plug in the values. What was the final speed? It was 6. What was the initial? It was 4. So your answer will be 4 kg meter kg meter second minus 1. This is actually change in momentum. What is that? It is your change in momentum in this case. Mariam, is it clear now?
Sir, could you repeat, please?
Yes. The values?
I mean, like,
Okay,
how
let's make
did you? Yeah, actually.
एक और एग्जांपल दे देते हैं. Khadija,
Yes, sir.
Khadija, are you there?
Yes, sir.
For example, if I have a body of 5 kg and it is moving with a speed of 7 meter per second, after some time, the mass of the body does not change, so it would remain 5 kg, right? It is 5 kg. Khadija, you have to take part in the game. So this is 5 kg, same mass, and now its velocity has been increased to 9 meter per second. Khadija will tell me what is the momentum of the body when it started its motion. Initial momentum. Let me
That
call
would
it
be
that it is its initial speed u and it is its final speed v. So yes, Khadija, what is its momentum? M into u.
yes, sir.
So 5 into क्या करोगी? 7.
7.
So your answer will be 35. Is it? Mariam, is it clear beta? Ariba, Mariam,
Yes, sir.
दोनों को
Got
clear
it.
है? Okay.
So you
Now
सब like
it's
एक ball का like momentum find किया ना?
हाँ एक जगह पे बॉल का मोमेंटम फाइंड किया है. Now for the second stage, the momentum of the ball is, because I told you that momentum velocity के change होने से change होता है ना, mass नहीं change हुआ तो it's not a big issue, but momentum change होगा. So again, mass into velocity at that point. So I just call that it is final velocity. तो मैंने उसको formula V कर दिया. Mass is 5 and what is final velocity? 9. So what did I get? 45.
Sir, तो
Okay.
basically हम like change of momentum का formula तब लगाते हैं जब हम इन दोनों का find करते हैं. अगर एक का होगा तो सिर्फ momentum का formula.
Yes, exactly. When you are not given the change in value, change in velocity or change in speed, तो आपको change find करने की जरूरत ही नहीं है ना, क्योंकि change हो ही नहीं रहा. Are you getting my point?
Yes, sir.
वो तो change तभी आएगा when velocity is changing. Sorry, I just not considered कि आज मेरा माइक थोड़ा सा ज्यादा सेंसिटिव है, तो मैं थोड़ा ज्यादा ऊंचा बोल जाऊंगा, तो अगर कोई ज्यादा कानों में हेडफोन लगा के सुन रहा है तो वॉल्यूम लो कर दो बोले. I will go back to that mic. Don't worry. Just एक दो दिन के लिए मेरा ख्याल है it was having some I was having a trial on that one. So is it now clear? So actually, I calculated momentum on both the positions, but my question is still pending, and that question is with Ariba. Yes, Ariba. What will be change in momentum?
Sir, can we
Ariba, are
like
you there?
5 multiplied by 4.
No,
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 5,
no.
sorry.
I have calculated momentums on both positions. So how will I find the change?
Just 45 minus 35 then, which would give you 10.
Sure. Yes, Khadija, आप क्या कह रही थी?
sir kuch nahi, same thing. But won't we
Same
like
ना?
use, yeah, but like won't we like you know like use that formula?
यस, अब आप देखो, मैं वही फार्मूला यूज करने जा रहा था. एक्चुअली द सेम थिंग कैन बी डन बाय यूजिंग m into v minus u. So if it is giving you the same result, it means that is the same thing. So mass is 5 kg and final speed is 9. Initial speed is what? 7. So will it give you the same number?
Yes, sir, but like paper में तो वो like पूरे equation मांगेंगे, so we can't do it directly.
यस, आप
Huh?
आप ये कर सकते हो. देखो, आप दोनों काम कर सकते हो पेपर में. पेपर में आपके पास दोनों की चॉइस होती है, बिकॉज यू आर सपोज टू कैलकुलेट मोमेंटम. सो व्हेन यू आर सपोज टू कैलकुलेट मोमेंटम, यू कैन राइट P2 minus P1 or P final minus P initial. And if you calculate P final at a separate place, that it is equals to MV, and you calculate P initial at a separate place, and you just write MU, and then just multiply these all numbers and get a compact shape. ये जैसे मेरे पास ये 45 आ गया था, and this was 35, and then plug in these values here. So examiner will award you marks, no problem. But it is bit time taking. I mean, I understand that it is time taking. So instead of this, I've just not recommended. What I recommend that is just use the simplest one, m into, because mass तो change नहीं हो रहा ना. So why you are going to drag the mass two times in your formula? So just put those numbers in operation which are being changed. आपका v और u change हो रहा है. Just plug in the value, mass की value यहाँ place कर दो. So value of velocity was changing from 7 to 9. तो आपका आंसर हाजिर खिदमत है. Is it?
Oh,
Actually,
got it, sir.
ये बात समझ आ गई सबको?
Yes, got it, sir.
Yes, sir.
Yes, very good. The situation changes when a body gets rebound. आपने इस वर्ड को हंट करना, हंट समझते हो?
Yeah.
Whenever this word is given in the statement और ये लिखा हुआ हो bounces back, ठीक है? These are the key words for your momentum. मैं कह रहा हूं कि अगर आप लोगों ने ये वर्ड्स हंट कर लिए ना एग्जाम में from your statement, you will never make a mistake in your calculation. Just hunt it. जिसको हम लोग कहते हैं ना वर्ड हंट. सो दैट इज अ प्रॉपर टर्म हेयर. आपने वर्ड्स को हंट करना है, रिबाउंड ढूंढना है, और बाउंसिंग बैक का कॉन्सेप्ट ढूंढना है. देन अब मैं आपको एक सिचुएशन बता रहा हूँ, इंटरेस्टिंग सिचुएशन. आपको सबसे पहले तो ये पता है कि वेलोसिटी रिवर्स होती है, डायरेक्शन रिवर्स होती है तो वेलोसिटी नेगेटिव हो जाती है ना?
Yes.
Okay, so if this is a ball of certain mass, which is actually of वही सेम बॉल था, इसका वेलोसिटी हम लोग कर लेते हैं, इट इज सॉरी mass हम लोग कर लेते हैं 5 kg, and it was moving at a speed of 9 meter per second. There is a wall ahead, ठीक है? And when the ball hits this wall, it rebounds, ठीक है? When it rebounds, what what amount of speed will it have? Definitely थोड़ा सा हमारे पास speed कम हो जाएगा. So let's say it is moving with a speed of 7 meter per second in this direction. अब आप मुझे ये बताइए कि what will be momentum, initial momentum? Will it be 45 kg meter per second? Isn't it?
Yes, sir.
What
Yes,
about
sir.
the final momentum?
Um,
Ball
five
वही
into
है,
seven, 35.
35 kg ms minus 1. But the game is, it is negative because velocity is negative. So remember one thing, that here when you are going to change, or when you are going to find the change in momentum, actually the change in momentum will be, change in momentum in this case is p final minus p initial. Okay, till this point are you people agreed with me?
Yes, sir.
फाइनल मोमेंटम आपका हो गया -35, इनिशियल मोमेंटम आपका हो गया -45. So I will simply add them together. It would give you 80 newton, sorry, 80 kg meter per seconds. That is your with negative sign. So this is what, in case of rebound, in case of rebound, actually what did you do? Actually, what did you do? Actually, you have added the momentums, right?
Oh,
Mathematically तो
yeah.
आपने यही किया ना?
Yeah.
So you have added the momentums. So remember one thing, that when your balls bodies are having a rebound case, add the momentum simply. Just give a negative sign. आपको एग्जामिनर नेगेटिव साइन पे भी पेनलाइज नहीं करता, इतना जेनरस एग्जामिनर है हमारा. बट रिमेंबर वन थिंग, व्हेन यू आर हैविंग दिस सिचुएशन, जस्ट ऐड देम. अब मैं इसी को एक फॉर्मुलेशन में लेके आ रहा हूँ. खदीजा वाज आस्किंग मी अबाउट फार्मूला. Khadija, what is the final momentum? P final minus P initial. So if I just write the number, final momentum is M into V, but with negative sign, is it? And it is M into U. So ये जो बीच का negative sign है ना, that is your formula sign. So just take negative M common. M common ले लें तो क्या होगा? Are you people agreed? Will it be that what I
We might.
wrote?
Sir, could you
We
give one
might.
more example?
Yes, I will. I mean, should I explain it again?
Yes, please.
Yes, I was saying that if I have this ball and the ball is having initial speed something 45 kg mass, and initial speed was 9 meter per second, then its initial momentum is 45 meter per second, kg meter per second, right? But it rebounds with this speed and towards left, so it is taking its velocity as negative sign. हम लोग rebound के केस में, because velocity is a vector quantity, so when its direction is reversed, we take it negative. So it is -7 meter per second, right? Are you getting it?
Yes, sir.
So final momentum is -35 kg meter per second. So when I just consider this equation of to find the change, so change का formula क्या हो गया? P final minus P initial. So -35 is final momentum, and this negative sign is formula sign. So don't make it as your sign of I mean direction. ठीक है? तो आपके पास यहाँ पर क्या हुआ? This 45 is basically the initial momentum. So just I added them. Na, actually what I did, action क्या हुआ आपका? Your action was you added the momentums. मैं उसके ऊपर आ रहा हूँ. The same is done here when you are having delta p is p final minus p initial. What I did, I just put minus mv for final momentum as, and mu for initial momentum. मैंने minus m common ले लिया, and I got this one, v plus u, because negative negative it would become positive. So actually when you are going to find momentum change in case of bounce back and rebound, your formula will be simply m into v plus u. That's it. If you write the negative sign or not, it does not matter at your level. एग्जामिनर आपको अभी फेवर देता है इस लेवल पे, आईजीसीएसई के लेवल पे, बट एग्जामिनर नेवर गिव्स यू अ फेवर of the sign. If you have subtracted the numbers in case of rebound, you will be penalized. You have to add the velocities in case of rebound. That's it. This is only for rebound. Only for rebound. Rebound का मतलब bouncing back. Okay. So when I use this concept, I just reach to a point कि मैं एक और क्वेश्चन कराता हूँ, डोंट वरी, उसके बाद फिर आप लोगों को क्लियर हो जाएगा. फॉर एग्जांपल, अ बॉल is being dropped here with a certain speed. Its mass is, let's 5 kg, वही ball है, and the ball is dropping down, and when it hits the ground, its velocity is, how much velocity does it have? Its velocity is, let's say, 9 meter per second. वही ऊपर वाला बॉल ही है तो 5 kg होगा यहाँ पे. Then it rebounds, bounce back करेगा ना definitely ball, right?
Yes.
For example, it is rebounding with a speed of 6 meter per second in the upward direction. Calculate change in momentum. जल्दी बताइए, शाबाश. What will you do? Calculate change in momentum.
V plus, I mean MV plus
Do
MU.
nothing. ऐसे कर दो. Keep this m out. Add the velocities inside. That's it. आसान तरीका बता रहा हूँ ना एग्जाम के लिए. Just put m out. M is how much? 5. और दोनों velocities को add कर दो. So 9 plus 6. Your answer is how much?
15 into 5. 70.
Is it clear?
Yes, sir.
Zainab कैसी हो? Okay, sorry. I thought that you, mean Khadija, you joined again?
Yes, sir.
Okay, so is this all clear to everybody? Check this one out, please.
Yes, sir.
Okay, so right from here, I'm going to switch the topic of forces again. मेरा बेटा, मैंने ये जो सारी मेहनत की है ना, मैंने इसलिए की है. एक्चुअली न्यूटन ने ये जो लॉ दिया था ना, ये उसने यहीं से दिया था, न्यूटन्स सेकंड लॉ. ठीक है, फोर्स एंड मोमेंटम के टॉपिक. जस्ट आई विल गिव 5 more minutes फ्रॉम योर प्रीशियस टाइम, लेकिन आई होप कि आई विल बी एबल टू वाइंड अप दिस टॉपिक. सो नेक्स्ट टाइम जब हम लोग पढ़ेंगे तो वी विल बी टॉकिंग अबाउट लॉज ऑफ मोमेंटम. ठीक है, फोर्स एंड मोमेंटम का क्वेश्चन आपका ये है, आपने डिफाइन ये करना है. ये डेफिनेशन है प्रॉपर, यू हैव टू रिकॉल इट, प्लीज रिकॉल इट. ठीक है, सऊदिया में हो तो आपको रिकॉल करने के लिए आसानी हो जाएगी. ठीक है, डेफिनेशन इज दैट रिजल्टेंट फोर्स इज rate of change of momentum. Resultant force is equal to rate of change of momentum. Rate of change of momentum. ये बात याद रहेगी? Will you be able to remember that? अब आपको ये तो डेफिनेशन याद करनी है, but I will give you an equation for this purpose, that your force, resultant force is equals to rate of change of momentum. क्या होता है? Change in momentum divided by time. That's it. So you have to recall this formula. Don't forget my complete 35 minutes explanation for change in momentum, please. अगर आपके पास change in momentum can be either m into v minus u, or it can be change in momentum is v plus u. That's it. I told you this is just for bouncing back. Whenever this formula will be used, or this word will be used, bouncing back or rebound, तो आपने ये formula use करना है. So it means my force is now either m into v minus u divided by t, or my force is m into v plus u divided by time. ठीक है? Is it clear to you? So here we go. This is for rebound case, and this is for simple no rebound. So this is actually the situation of force and momentum, right? Force and momentum. ये किसका concept है? This is the concept of force and momentum. Is it clear to all?
Yes, sir.
बस फाइनल एक चीज आपके साथ डिस्कस करनी है, and that is your impulse. Impulse is basically change in momentum. Change in momentum. ठीक है? Change in momentum. So, and that is extracted from which formula? That is extracted from, that is delta p is equals to f times t. That is extracted from this formula. Check this one out. आपके पास यहाँ पे था ना? So if I use this delta p, that will be equals to f times t. That's it. So I'm bringing this formula from here. So impulse is actually your change in momentum. So whenever you are asked to find the impulse, you will just put this other time over. That is your calculation of f into t. So remember one thing, that is why I use the chain formula of momentum as Newton second also. I mean, unit of momentum is Newton second also, right?
Yes, sir. Got it.
ठीक है? We will discuss furthermore in next lesson, inshallah. I will give you some of the examples and we will discuss that. So please don't forget to recall all of that. Once you are done, just review karna hai, nothing else. Just review these all, right? And then I will inshallah I will send you some of the questions which I think that they must be learned by you to reinforce this topic, and then it would be all clear. Okay?
Yeah, but sir, would you send the notes, like these notes after we finish the chapter, or like would you
No,
send
no,
it
no.
right?
You send them
अभी
right
सेंड
now?
कर दे, अभी सेंड कर देते हैं, अभी सेंड कर देते हैं. मुझे आज पता है आज आप लोगों ने कोई उस तरह एक्टिवली पार्टिसिपेट नहीं किया. सो आप लोग जाहिर है अभी जाके नोट्स पढ़ोगे और फिर उसके बाद इनको पक्का करोगे. इजंट इट?
I mean, yeah,
Yes.
I do need to go through the notes.
ओके, मैं बताऊंगा आपको, मैं सेंड कर देता हूँ अभी. ओके, सो आई एम गोइंग टू सेंड यू दीज नोट्स इंशाल्लाह.